The red desert is waiting for us, cold, silent, and completely dead. For billions of years, it has just been sitting there, a rusty ball of dust and rock orbiting the sun, completely indifferent to the universe. But right now, on a small, fragile blue planet millions of miles away, thousands of minds are working day and night to do the unthinkable. We are planning to wake that dead world up. We are preparing to leave our home, the only place that has ever kept us alive, and journey into the deep black void to build a new civilization from scratch. This is not a movie, and it is no longer just science fiction. The blueprints are being drawn, the rockets are being tested, and the countdown to the greatest adventure in human history has already begun. Think about the sheer scale of what we are trying to achieve. Every single thing you see around you right now, the air you breathe, the water you drink, the soil under your feet, the thick atmosphere that protects you from deadly space radiation, all of these things are given to us for free by Earth. We take them for granted because our planet has spent billions of years evolving into a perfect cradle for human life. But on Mars, none of this exists. If you step outside on Mars without a spacesuit, your blood will literally boil because the atmospheric pressure is so low. The air is almost entirely carbon dioxide, a toxic gas that would suffocate a human in a few gasps. The temperatures drop to a freezing minus 80 degrees Fahrenheit on a regular night and can plummet even lower near the poles. Furthermore, the ground is covered in toxic dust, fine enough to penetrate the smallest seals. It is a world designed to kill us in a matter of seconds. Yet despite these terrifying odds, we are choosing to go. The journey itself is an architectural and psychological nightmare. To get to Mars, we cannot simply launch a ship whenever we feel ready. We have to wait for a specific orbital alignment of the planets, known as a home-on transfer window, which happens only once every 26 months. When that window opens, we have to launch a massive spacecraft into the dark void. The trip will take anywhere from 6 to 9 months, depending on the propulsion technology used. Imagine being trapped in a metal tube the size of a small apartment with a handful of other people, hurtling through deep space at over 20,000 miles per hour. There is no turning back, no emergency resupply, and no rescue mission. Once the engines fire and you leave Earth's orbit, you are completely committed. You are floating in a cosmic shooting gallery, exposed to unpredictable solar flares and high-energy cosmic rays that can easily penetrate aluminum hulls, damaging your DNA and drastically increasing your risk of cancer. At the same time, the microgravity environment acts as a silent thief. Your muscles will begin to waste away in zero gravity because they no longer have to support your weight, and your bones will lose critical density every single day. Even with rigorous daily exercise routines using specialized resistance equipment, astronauts will arrive at their destination significantly weakened, yet they must immediately face the most grueling physical challenges of their lives. And then comes the most terrifying part of the entire mission: landing. Mars has just enough atmosphere to create extreme heat when a spacecraft enters, but not enough atmosphere to slow it down safely with conventional parachutes alone. Engineers call this phase the 7 minutes of terror, and for good reason. The spacecraft has to hit the Martian atmosphere at 17,000 miles per hour and slow down to a complete stop in less than 7 minutes, entirely on automated computer control. The distance between Earth and Mars is so vast that radio signals take several minutes to travel one way. If something goes wrong during landing, Earth will not even know about it until long after the ship has either safely touched down or become a new crater on the Martian surface. The automated systems must perform hundreds of critical actions flawlessly, deploying supersonic parachutes, firing retro rockets, and perhaps utilizing sky cranes or massive airbags. The astronauts will be completely on their own, sitting in absolute silence as the automated systems determine their survival. But let us say the ship lands safely. The dust clears, the engines shut down, and the crew looks out the window at their new home, a barren vista of rust-colored dirt and boulders. What happens next? The first few days will be a frantic, exhausting scramble for survival. The very first priority is not exploring, collecting rock samples, or taking pictures. It is finding a way to breathe and drink. The astronauts will have to rely immediately on mechanical systems like MOXIE, which extract oxygen directly from the thin Martian atmosphere through solid oxide electrolysis. They will have to deploy massive arrays of solar panels or deploy small nuclear reactors to get power. Without electricity, the vital heating systems will fail within hours, and the crew will freeze to death before the sun sets. Initially, they will live in the very transport ships that brought them there, or in small, inflatable habitats that must be quickly covered in feet of Martian soil by automated rovers to shield them from the deadly solar radiation raining down from space. Water is the key to everything. Without it, the colony dies in a matter of days. Luckily, we know Mars has water, billions of tons of it, but it is all frozen into ice, trapped beneath the polar caps and buried deep under the dirt. The early pioneers will have to become heavy laborers and miners, digging up thousands of pounds of frozen soil, melting it down, and purifying it of heavy metals. This water will not just be for drinking. By splitting water molecules into hydrogen and oxygen through electrolysis, the colonists will create the very oxygen they need to breathe and the liquid methane rocket fuel required to send ships back to Earth. Mars will force us to recycle everything with absolute efficiency. Every drop of sweat, every breath of moisture in the air, and every bit of human waste will have to be captured, treated, and reused. There is zero room for waste or carelessness when nature is actively trying to kill you outside the airlock. As the colony grows from a few dozen astronauts to hundreds of scientists, technicians, and engineers, the architecture will have to evolve rapidly. We cannot ship heavy building materials from Earth because it is simply too expensive. Every single pound of equipment sent to Mars costs thousands of dollars in fuel and rocketry. The solution is to build with what is already there, a process known as in situ resource utilization. Future Martians will use automated three-dimensional printers to mix Martian regolith with binding agents to build massive interlocking domes over their habitats. They might even move entirely underground, establishing colonies inside giant lava tubes left behind by ancient volcanoes billions of years ago. These subterranean cities would provide perfect natural protection against radiation, extreme temperature swings, and the meteorites that constantly bombard the surface without burning up. Imagine an entire society living beneath the red dust, lit by artificial sunlight, growing crops in giant hydroponic farms and walking through underground plazas. Food production will be another massive hurdle that requires constant scientific monitoring. The Martian soil is toxic, packed with dangerous chemicals called perchlorets that disrupt human thyroid function. You cannot just plant seeds in the ground and watch them grow like you would on Earth. The first farmers on Mars will have to thoroughly wash the soil to leach out the toxins, or use advanced hydroponic and aeroponic systems, growing plants in nutrient-rich water or mist without any soil at all. The diet will be mostly plant-based. Lots of potatoes, genetically modified grains, leafy greens, and cultivated insects for protein. Real meat will be an unbelievable luxury, grown in laboratories from animal stem cells. Life will be tough, strictly rationed, and highly disciplined. Every single person will have a vital job to do, from maintaining the air scrubbers to monitoring water purity. And the survival of the entire community will depend on everyone doing their part perfectly. There will be no room for dissent or negligence when a single open valve can depressurize an entire neighborhood. So why do it? Why spend trillions of dollars, risk human lives, and dedicate our best minds to colonizing a frozen, toxic wasteland when we have so many urgent problems right here on Earth? The answer is long-term survival, not just of individuals, but of the human species as a whole. History shows us that planets are dangerous, unpredictable places over cosmic timescales. Asteroids hit, supervolcanoes erupt, deadly pandemics emerge, and nuclear weapons continue to pose an existential threat. If all of humanity stays on just one planet, we are keeping all our evolutionary eggs in one fragile basket. A single catastrophic event could wipe out everything we have ever built. Every book written, every song composed, every scientific discovery made. By becoming a multi-planetary species, we are buying an insurance policy for consciousness itself, ensuring that the light of human intelligence continues to burn even if darkness falls on Earth. But there is an even bigger, more breathtaking vision for Mars, one that spans centuries and generations. Right now, Mars is a dead planet, but it does not have to stay that way forever. Some scientists believe we can terraform Mars, meaning we can fundamentally reshape its climate and environment to match Earth. This would be the largest, most ambitious engineering project in human history. It would begin by warming the planet up to trigger a self-sustaining greenhouse effect, We could do this by building giant automated factories on Mars that pump super greenhouse gases like chlorofluorocarbons directly into the atmosphere, or by steering icy comets from the outer solar system to crash into the surface, releasing massive amounts of water vapor and nitrogen. We could even place massive, ultra-lightweight mirrors in orbit to reflect sunlight onto the polar ice caps, melting them and releasing billions of tons of trapped carbon dioxide. As the atmosphere thickens with carbon dioxide, a runaway greenhouse effect would take over, mirroring the process that keeps Earth warm, but on a much larger scale. The planet would start warming up on its own without further human intervention. The frozen subterranean rivers would melt, and liquid water would flow across the Martian surface for the first time in billions of years, carving out new lakes and oceans. Rain would fall from Martian clouds onto the parched Earth. Once the planet is warm enough and has stable liquid water, we could introduce genetically engineered microbes, lichens, and cyanobacteria. These tiny resilient organisms would feast on the abundant carbon dioxide and begin pumping out oxygen through photosynthesis. Over hundreds or perhaps thousands of years, the red planet would slowly turn green with vegetation and eventually blue with deep oceans. Future generations would be able to walk on the surface of Mars without a heavy spacesuit, breathing the natural air and looking up at a blue sky. Of course, this grand vision faces incredible skepticism and debate within the scientific community. Many argue that terraforming is fundamentally impossible because Mars lacks a strong global magnetic field. Without a magnetosphere to shield it, the powerful solar wind would simply strip away any new atmosphere we try to build, just as it did billions of years ago when Mars lost its water. But humanity is nothing if not inventive when pushed to the limit. Scientists have already proposed building a giant artificial magnetic shield in space, placed at the stable Lagrange L1 point between Mars and the Sun, to act as a massive deflector shield for the entire planet. This shield would block the solar wind, allowing the atmosphere to thicken naturally over time. The engineering challenges are mind-boggling and require materials we cannot yet manufacture at scale, but they are not theoretically impossible, according to the laws of physics. It is simply a matter of technology, time, and collective political will. The colonization of Mars will also fundamentally change what it means to be human, both culturally and biologically. Mars has only about 1/3 of Earth's gravity, an environmental factor we cannot easily change. Children born on Mars will grow up significantly taller and leaner than their terrestrial ancestors. Their bones and muscles will adapt to the lighter environment, developing completely different structures. If they ever choose to visit Earth, they will feel incredibly heavy, as if they are being crushed by an invisible weight, and their hearts will have to work 3 times as hard just to pump blood through their bodies. They will be a new branch of humanity, Homo Martianus. They will develop their own distinct culture, their own accent, their own laws tailored to a world where air is a commodity, and eventually their own independent government. The vast separation of millions of miles of empty space will inevitably lead to the birth of a completely new civilization, with its own unique perspective on the cosmos and human destiny. We are standing at the absolute edge of a new era, a pivotal moment that will be remembered for the rest of human history. The generation that will first set foot on Mars is alive today. They are sitting in classrooms, playing video games, and looking up at the night sky, completely unaware of the role they will play. The decisions we make over the next few decades will determine whether we remain a single-planet species, forever bound to the place of our birth until our time runs out, or whether we take the ultimate leap into the great unknown. It will be dangerous, it will be incredibly difficult, and we will undoubtedly lose brave souls along the way. But the alternative is to stay here, look inward, and wait for the inevitable end. The red planet is calling to us, a blank canvas for the future of humanity, waiting for us to make the first bold stroke.